you presenting something?
So
chat first?
Well, yeah. What I thought was maybe we should just chat first, and then after we could show some stuff.
Sure.
As I mentioned to them, I didn't prepare anything, no PowerPoint presentation or anything.
PowerPoint sucks.
Yeah, exactly.
But I think it would be really useful, and from what I gather from Goodney, one of the goals of the meeting discussion today is for you guys to find out what my experience is like being a user. And I'm happy to share that. And in that process, I'll probably learn a whole bunch of things, I'm sure. Yeah.
Yeah, I think it would be, at least from my perspective, that would be super valuable. Of course.
Yeah.
Yeah.
Right. So we can plug in later, I guess.
Sure.
Yeah.
That sounds good. All of mine. Cool. Rowan, feel free to just jump in when you have thoughts.
Yeah, of course. Yeah.
Sounds
Hey, Ron, nice to meet you.
Oh yeah, you guys never met?
No, I haven't. Maybe in person or something.
Friends from the internet.
Yeah.
cool. So where do you sort of want to start? Are there aspects on like
Sure.
what we're doing or?
Well, I first want to thank you guys for inviting me out because I really, really enjoy working with smart people. And all of you definitely fall into the category of smart people. So, and it's really helpful for me and stimulating for me to be able to work with people who are doing stuff at the cutting edge. Like, in my opinion, you guys are there on the cutting edge. So, so thanks for inviting me, and many thanks to Dom and to Goodney both for helping me in every step that you have and getting me up to speed and running.
It's good to have you on board.
Yeah. But so just a little tiny bit of background for those of you who don't know me. My undergrad degree was in geophysics. And then after that, I moved on and did geology, and I studied volcanoes for a long time. And then when I finished my PhD down in Seattle, University of Washington, I went back to geophysics because the places to get a job was with geophysics firms. So I've worked for a variety of geophysical data acquisition companies, either airborne or ground-based acquisition companies. I've worked a lot on the side of geological interpretation of geophysical data and models. And that's really where I've sat for most all of my career, is being the geology guy who can speak geophysics and being the guy who understands enough about geophysics that you can translate it to the geologists. And that's been a really good spot for me. And that's kind of where I want to remain. And that's why, obviously, I really enjoy working with a lot of smart people like you, because I don't have the background or the skill set to do all of the programming and hardcore inversion that you guys do. But I want to grab that and build on that, and then transfer it over to the geologists so that we can get some really real geologic meaning that we can constrain really well using the most cutting edge geophysics. So that's kind of where I'm at. And hi, I'm Jack. Nice to meet you. Hey, nice to meet you.
So we are here.
That's all right. That's all right. And so I guess to polish off my background, as Dom knows, I worked for 4 years at Mira Geoscience, and so was involved with a whole array of projects that used a whole bunch of different types of geophysics and 3D, 1D, 2D, or 3D inversion modeling of all those different types of geophysics, and then try to get a geologic interpretation out of it. So I'm familiar with, to a certain extent, with the UVC codes, but now I'm on the geothermal energy side of things, doing the same exact thing: geology, geophysics, 3D modeling, and visualization, but mainly for the geothermal energy resources. And that's what I want to use SimPEG for, is to assist with rigorous, evidence-based 3D exploration for geothermal energy resources. And it's particularly challenging to do geothermal exploration because unlike in the oil and gas industry, seismic works awesome for oil and gas. Seismic doesn't work awesome for geothermal because a lot of times you're working in hard rock environments, not rather than sedimentary basins. And in my opinion, geothermal exploration is more difficult than mineral exploration because you don't have these incredibly whopping physical property contrasts, like some crazy dense VMS or some super magnetic something else. And so what you have to do, in my view, is that you have to use all your geophysical tools in your toolbox, along with as much geology as possible, to try and build that 3D geoscience framework where everything fits together and gels. It's a real hard sell to people who don't understand or have never been, have never considered that approach before. But I think it's the best approach. As you guys all know, there's no one, what do you call it, the silver bullet method. So we've got to use them all. And in the geothermal industry, there's resistance to a certain extent of doing things in 3 dimensions. But luckily, you guys have all helped create the tools to do geophysics in 3 dimensions, and their tools to do geology in 3 dimensions. So I think that's the direction we all have to go and keep pushing the laggards to get up to speed. So as far as my experience with SimPEG, it's great that it's originally based on the UBC set of codes, because for anybody who I talk to who has a familiarity with UBC and the codes that were developed over many years by Doug and his group, I can just tell them, hey, SimPEG is this fantastic thing that's just like the UBC codes. It's based on the same equations and know-how and everything, but now it's open source. That grabs people's attention and makes them interested, and automatically gives it some street cred, which is good. And I've talked to a number of different organizations to try and get them interested, because I'm in a position now that if I want to do more of these projects, I got to get anybody else interested and excited about it. And if they want to call you guys up and interact directly to use SimPEG on their own or adopt it and use it on themselves, I think that's a win-win for everybody. So I've talked to, let me see if I can remember, I've talked to the US Geological Survey, the Nevada Bureau of Mines and Geology, which is the State Geologic Survey of Nevada, the Utah Geologic Survey. And in those 3 groups, I've either spoken with geophysicists who work with them or with very geophysics savvy geologists who want geophysical understanding. And they've been very positive about SimPEG, which is great. I've talked to the Washington State Department of Natural Resources, which is sort of like the state survey there. They don't have geophysicists on staff, but they see the value. Who else have I talked to? I haven't talked to anybody internationally outside of North America yet, but those are the main groups I've been communicating with. So that's kind of where I'm at, I guess, with that sort of stuff. As far as my actual user experience, so I learned some programming back in university, but I'm not a programmer now. And so Dom has helped me out immensely by providing me with some scripts that will run a SimPEG inversion. And then it's up to me to make little edits to it. That works for me very well right now. I can imagine that for some people that might not work, because they might get scared off by that. It was overwhelming for me to, in order to get this whole process started, to do GitHub and source tree and Spider, and then you haven't even touched SimPEG yet. But Dominic, you know, shepherded me through that, and it works.
It's a learning curve for sure.
And so for a new person, there's this terrible fear that you'll change one thing, you don't know what it was, and then it won't work anymore, because there's so many different, you know, knobs to turn and moving parts. But as far as once it does work on my machine, it's been fantastic, because I can, and the fact that it uses standard UBC file formats is great. because I can create, the mesh files and the ops files and all that kind of stuff, and try different things
Outside.
I do it outside, and then I'll say I'll change the grid size on the mag data that I'm going to invert. Maybe I want to do a coarse, maybe I want to do it fine. What's it going to look like for the difference in the inversion output? I can do that. I imagine anybody else could do that as well. So that's not a showstopper, really, which is great. As I learn more about what changes to make in the script, then I can test other options, whether it's changing the depth weighting or changing something else, because there's so many different dials to turn.
Yeah.
But having a grocery list, I guess, of what are the knobs that I can turn, and where do I look in order to go to the right spot in order to change those knobs, and then also what numbers do you put in order to change the knobs to the degree that you want.
Yeah.
That's still a mystery for me, simply because I haven't had enough time to commit to that, but also because I really don't know where to go.
It's very.
Yeah.
That's actually something.
That's actually a mystery for us too. That's research too.
No, but I mean, all the switches. And
Yeah, I mean, we know
Yeah.
where they are, but
And
it's
they're
how
kind
you.
of hidden under the layer.
Yeah.
And inside the functions.
That's something that I've been trying to work on with my personal research repository. Just like playing around with a few ideas of how to actually wrap SimPEG so that I can basically, because the way I like to work is working with the Jupyter notebook to set things up, because then I can look at my mesh and like look at all of the pieces and then kick it over to the cluster to run a forward simulation or inversion, and then get my results back and just reload it all. And so I think that there's some ideas in the way we've set up like simulations I can show you quickly, because I'd be curious to get. Sorry, am I crazy?
So the interaction to UPC files, that's something you wrote there for the Max code specifically, or?
Yeah. Every time I touch a piece like DC or grab or Mang, I always write the IOs because I want to read it.
Yeah.
Right up.
You have old files? Yeah. No, I mean, that's super interesting. Like, I guess the gateway into kind of what is the gateway into SimPEG? And so, like, it'd be different for people that are used to different codes.
Yeah.
I find that I've been working with the menu of A, and they're used to the Baruch code. It's like formulated, like uses different coordinate systems. So it's something that is good for everybody to have to go through, but you don't really have to want to go through. Like, because it's just like, you do it once, and you should just be done and be able to do it like again and again and again. So I agree, that's kind of something we need to think about.
Yeah, it's like figuring out how to properly expose knobs. Because one of the things, well, I mean, the stuff we've done with the objective functions, I think has maybe given a few ideas in there. So we recently went in and like rewrote how we formulate the inverse problem, so that you actually can go in and start thinking about doing joint inversion and those kinds of things.
Oh, great, yeah.
So you can play with those knobs, but I think in that, there's also a lot of things that came to the surface in terms of how do we expose knobs in a way that makes sense. So that's
maybe also just a documentation, right? And it's maybe because
Yeah,
you just
that's
don't know
fair.
they are there.
Yeah.
If you know how to interact with it, that's like, this is all the things you can do and how to interact with it.
Yeah.
That might just be easy.
Yeah. Or having that grocery list, even if I read the documentation and I don't understand it, then at least I know that that thing exists.
Yeah.
It can be turned, and then I can ask for help.
Yeah.
I find that I've gotten the question several times now in the last couple of weeks, like, where's the manual?
Yeah.
Where's the manual to code?
Yeah.
Because that's just how certain people interact, and I was like, maybe it would just be a good idea to compile like into a manual at some point with like stable releases at least.
Yeah.
Or like set it up in kind of more of a, have a manual page or something. I don't know. I'm actually just thinking a lot about it.
Yeah, well, I mean, I think in a lot of ways, like formalizing a bit of how we like state the problem, things that we're saving. One of the things that I found in setting up something like this, so this is actually like all that I use to run a forward simulation and this repo is kind of chaotic because it is my research repo, but trying to basically state where my different assumptions are, because that's really what exposing knobs means. It's like where are all of the assumptions in the code. So in this case, like not exactly a great name, but these are my casing parameters. I'm doing a lot with electromagnetics and steel casing. So I've just created basically a way to set up, like here are all my parameters that describe a pretty standard model of a cased well in a layered space.
Okay.
Based on that, then building a mesh, and then whatever kind of source I want to use, and then the outputs you want to save. And so I think that there's some interesting things in perhaps trying to move stating both the forward and the inverse problem in terms of sets of parameters, and basically being able to write out like what is the file that states all of the parameters that I need to run the inversion. Like what is my grocery list for the inversion?
Yeah.
Because if we can actually standardize that a bit and write that out so that it can be saved and recreated and all of those kinds of things, I think that that not only helps us run more reproducible things, it actually helps clarify where the assumptions are in the problem.
I did, I'll mention that as a newbie, I did read the paper, was it the 2015 paper?
Mm-hmm. Yeah.
And I found it very helpful, very insightful, but I didn't feel that that had the grocery list in it.
Right.
Yeah. But that was great, and I would recommend anybody who wants to start with SimPEG to read that paper because it provides the overview.
Yeah.
Yeah.
It's funny because you kind of go into the way that the input file, that the EVC uses, but you're right, instead of it being a static input file, it could just be a dictionary like a JSON, right? And you just like add as many arguments as you want, referring to that shopping list. Like I want to hit this one, just add them all up.
Yeah.
And then somehow the code just compiles it all and run the forward or the inverse.
Yeah, and because what that looks like in terms of, and this is again a little, maybe I'll show you the mesh. And so, yeah, what this looks like is, you document each of your properties, and these are the things that I need to save to recreate it. So my cell sizes, all that kind of stuff. And then we can actually, like, here's all of the instructions that I need to create a mesh. And then I can just go and basically take those and build the mesh.
And if you don't provide them, then it's just default value.
Yeah, there's defaults, or and this is something that too you can be very careful in setting up your own workspace and environment. Is do you actually want this thing to have a default or not? Because in some cases, like you shouldn't, and that should be something that the user needs to think about. Yeah. But in some cases, like sure, it makes sense to have a default, like a number of padding cells or something like that. You can have those kinds of defaults in there. Yeah, so like I think actually looking towards something like this is a way to build a laundry list. Because then it's also all completely documented, like automatically, which is quite nice.
So that probably gives you all glossary.
Yeah, so I can show you what that actually looks like. Yeah, so if I go in and then look at my mesh, it goes in and documents all of the knobs.
Yeah, I think that's probably what you want. Right? Like those are all the knobs that can play with that. It could be overwhelming at least, but that's
a start.
The reality.
Yeah.
So this is using the property.
Yeah, this is using properties.
Yeah, we can, it's probably something we should put on SimPEG, prioritize this to propertize a lot of the things, because it is such a powerful package.
Yeah.
So that's essentially just it's a tool that 3 I guess is developing, and it's just meant to make the coding more consistent and make some tasks in the coding, adding like documentation and making sure that you can save them in a consistent way, for example, just takes care of it for you. So it's like an enforcement tool of you doing the coding properly.
Yeah.
So it's, I think it would be like with most of the classes, SimPEG would be super valuable.
Yeah, one of our developers, Franklin, has been working a lot on the properties repository, and that's in the one of the drivers of that is an open mining data format, which has gotten buy-in from the Global Mining Standards Group, the GMSG. So there's that acronym, the open mining format, is something that we're working with a lot of vendors in the mining space to try and get more consistency around data transfers between the various packages. So over the past sort of 6 months, we've gotten to a version like a 0.9 spec, which supports like point clouds and drill holes and surfaces and tensor meshes or regular block models. So it's a pretty cool place, and there's sort of a lot more buy-in at the moment from some of the big vendors, including like Leapfrog and some of the other mining vendors. So that's something that else is that is sort of on the horizon, and one of the sort of bleed overs of that work is a really good serialization format that Franklin has sort of generalized into the properties repository. And so that means that we can potentially take advantage of some of that serialization work just by implementing properties throughout the code, as Kutni was saying. And that gives us better documentation, exposes some of the knobs that Jeff, you were asking for. And it also like errors if you don't put a doc string in it. So you can't actually write the code, like the developer can't write the code until they've documented their stuff, which is a good thing. So that's just like some of the things that are on the go from my end. And yeah, I think absolutely getting properties more involved, and it's a pretty light thing, and it's really just documentation and sort of explicitly stating assumptions and where they are.
Yeah. So.
Okay, that sounds great.
And I'll ask Franklin in the next few weeks to give a bit more of a talk on that to our community and sort of how it might be relevant here.
Yeah,
That'd be great.
Have you guys had a lot of other universities start to adopt SimPEG and try it out, use it and test it and that sort of thing?
There are people who are involved at Colorado School of Mines.
Great.
And so there's like, in particular, Joe Capriotti has been contributing some code. There's people that I think that are using it, or at least sort of keeping tabs. U of C, there's a couple people who are interested. So it's starting to make its way out.
That's great.
Yeah.
Okay. Yeah, Goodney had mentioned to me that Colorado School of Mines was interested at some point.
Yeah.
And I was intrigued because they've done some work in the geothermal energy space, and they've done some work with the U.S. Geological Survey on some projects in Colorado.
Yeah.
Some hot springs, trying to probe the subsurface. If they could use SimPEG, I think that'd be fantastic.
Yeah. Is that with Yagwa's group
I
or?
don't remember actually.
Okay.
I don't remember.
There's something else. Yeah, there's like a resource, more resource oriented.
Yeah.
But I don't know. It's definitely not yet.
Yeah. And so the main applications you've been using, is it MT and then potential fields? Those.
I've been using potential fields. I think for MT applications, I'd want to partner with somebody.
Yeah.
But the 3D geological interpretation of an MT model result is something that I'd very much like to do.
Cool.
And then incorporate that with geological information.
Okay.
Yeah.
Yeah, nice.
What are you using for 3D right now to manage you do your interpretation?
For
Like seer mesh in 3D. What 3D software are you
for visualization,
Yes.
I'm using Geoscience Analyst and a 3D design software called Rhino.
Okay.
Rhino's a software company in Seattle, and they make a software where you can build anything. It's used for jewelry making, boat building,
Oh, really?
Oh.
anything.
Okay.
Yeah. And so,
Tech-based?
yeah, it
Okay.
originally came out of the AutoCAD world.
Okay.
So I use Geoscience Analyst because it's so easy to load geoscience data sets. All the file formats are pretty much there in Geoscience Analyst, but you can't build anything. So I build stuff in 3D, like 3D fault surfaces, topography, interpretation of a geophysical model.
Mhm.
I build all that in Rhino, and then I can visualize it in either platform.
Yep.
Like for example, Rhino, you could never import a GeoSoft grid file unless you wrote your own, thing to import it.
Right.
So I just use both as needed. And Rhino is incredibly low cost. For a university license, it's $200 forever.
Oh, wow.
Yeah. Yeah, and for a non-university, it's $1,000 forever.
Okay.
You never pay any maintenance fees or anything.
Yeah.
So that's very attractive. And then I've been talking to some people about Blender. It's an open source, free 3D design software. They use it in the film industry. And I haven't used it, but my understanding is you can build anything in it. What I've seen that's great about these 3D design software is your screen's divided up into four. One is the perspective view.
Yep.
And then you have the top down, the right side, and the left side.
Okay.
So you always know exactly where you are in 3D space. Because if you just have one view of the perspective view,
Okay.
it's hard to know where you are because there's no depth. Yeah.
Oh, that's cool.
So that's really helpful when you want to build something precisely.
Yeah.
And so that's what I've been using. And there's hundreds of thousands of users of Rhino software. So you can Google Rhino, my question.
And somebody's figured it out.
Somebody's figured it out. It's amazing.
Yeah.
Yes. Yeah. So I've been really happy with that so far. I'm certainly not an expert user of it, but I took a chance in getting the software. And so far I have not run into a showstopper yet, which I'm really happy about.
Oh, nice.
Yeah.
That sounds pretty good.
Yeah. And the company, a big, I think they're a geoscience consulting firm, Itasca. You guys ever heard of Itasca? They do all kinds of stuff from open pit mine modeling and slope stability studies, like, the finite element slope stability type stuff. And they do underground mine modeling. And what do you know, but they use Rhino to do that. So there's proven usage of this 3D design software in the geoscience community for geoscience.
What kind of format? Like, what's the, let's say, generative model? Like, what's the format that we use? Like,
It's just a format, I think they call it just 3DM or something like that. It's their own file format. But you can export, DXF files.
So that we can import that in the geoscience analyst?
Yeah,
Is it?
exactly.
Okay, analysts.
Yeah.
Yeah.
Yeah. So I've tried to limit myself to GIS shape files, text files, DXF files, and the occasional surfer grid file. And I think that's about it. And if I keep my life simple like that, it takes away a lot of headaches.
Yeah, no kidding.
Yeah.
I don't know, but that's right. So it's like the same thing with AutoCAD where you can like snap the points that kind of thing.
Yeah,
So,
for
wow.
sure.
Cool, for $1,000.
Yeah, for $1,000.
Have you tried Blender?
I haven't yet. And if I would have found out about Blender before Rhino, I probably would have tried it. What I've read on the internet is Blender, it has less documentation and it's a little bit more of a steep learning curve.
Okay.
It's also, I haven't really used Blender. It's more of a kind of visual design. It doesn't have the snapping mode, and you don't have like, it's kind of, I guess Rhino is kind of versus AutoCAD, but Blender is kind of more against Maya, which is also a AutoCAD company,
Oh, okay.
product,
Okay.
which is usually used for visual effects.
Yeah.
I know this because my wife does this.
Okay.
So it's like an animator.
Yeah.
So it's more for animation. So you can like, you'll take the mouse and you'll just like paint stuff on. And I'm like, how? Like I can't fathom some of the things she does. But you can't. She can't snap on the grip.
Yeah.
Because I'm like, that's total deal breaker for me.
Yeah.
One of the things about Rhino and its 3D visualization of geoscience stuff is that it's really for generating surfaces.
Okay.
And what I've done to try and have it visualize block models is first we imported a standard UVC block model, and we wrote a little script to do this, but manually built 196,000 six-sided cubes and colored the surfaces of those 196,000 cubes. It was really heavy.
Yeah. Really?
But it worked.
Yeah.
And they have a slicer tool, and so you can kind of
Okay.
slice it and pan through and look at it and stuff. But what we're doing now is we're just importing it as a point cloud, and then you color the points. And then in the new version of Rhino, you can actually create those points either as spheres, which would be fine,
Yeah.
but you can also create them as cubes,
Oh, okay.
which act as a point rather than a six-sided surface.
Yeah.
So it's a lot lighter and it's great. So I think it'll be fine for visualizing 3D block models.
Yeah.
Yeah. So that's what I'm using, and so far I'm really happy with it.
Got slow.
Yeah, man, absolutely. Another thing I'll share is that starting in the summer, I'm involved in a U.S. Department of Energy funded project in Nevada called the FORGE project. FORGE stands for Frontier Observatory something geothermal energy, resources and geothermal energy maybe.
Okay.
But anyway, I'm planning on using SimPEG. The goal is to model gravity data that they're going to collect this summer. Essentially, the geology out in this portion of central Nevada is a 3-layer of superficial sediments, and then tertiary volcanic rocks, and then crystalline basement rocks. And the idea is to better understand what the structure, faulting, and stratigraphy variations are in it's probably like, I don't know, 5 by 5 kilometer area. And they've got 3 kilometer deep wells in this area, so we'll have some downhole geologic constraints. We're going to collect density data from rock types in the surrounding mountain ranges that we believe are the similar lithologies to what we find underground.
Yep.
So we'll hopefully constrain the density, at least in a relatively good sense. And there's going to be seismic lines. So we'll use the interpreted seismic lines to try and find some horizons and create some initial starting surfaces so that the inversion modeling will start with a geologic framework which is close to reality. So that's the next big project that I'm going to use SimPEG for. The team's really excited. We're collaborating with Nevada Bureau of Mines and Geology, the U.S. Geological Survey, and a bunch of other groups. So I'm excited about that, and we'll probably lean on Dom a little bit for some help if that doesn't invade your PhD finishing too much.
That would be very exciting to, and I'd be certainly very interested to keep in the loop on that and see. I mean, because there's a lot of things, I think, pushing on data more, and especially bringing in a priori knowledge from seismic and geologic settings. That's not something we've pushed really hard on yet.
Okay.
So it would be great to get your thoughts and like use this as a bit of a scenario too to like, bring that game up.
That would be great. The vision that I have is I can take the interpreted 2D seismic images, post them vertically in Rhino, and then I can just digitize, the horizons.
Yep.
And then I'll just connect them up.
Yep.
You can do that in Rhino, build anything in 3D. And then I'll export those surfaces as DXF. And then where I'm going to need some assistance is everybody's presentation about that the diamond project.
Yeah. Those scripts are already written.
You created a three-dimensional geologic model with different domains, and then you use that to guide the inversion process. And so that was fantastic for me to see that, because I thought this can be done. And so I want to do something similar. We'll start out with a priori geologic model, populated with different physical properties, and then do forward modeling.
Yep.
And then maybe do some adjustments to the surfaces, which I can easily do in Rhino, and then do it again.
Well, yeah.
So I should ask, are there any obvious fatal flaws to that vision that you guys can see?
No, like that's great.
Okay,
That
okay, good.
Yeah, we can go even more. Like,
Yeah.
It's, you can invert more. Like you generate the surfaces. You can like say if you can generate a simple surface of like 3 layers.
Yeah.
Then you can even invert for
The surface itself.
Yeah.
Okay.
You can invert for the location of the surfaces.
Okay.
Like probably
fantastic.
invert for the thickness or the application.
Yeah, that's fantastic.
So
Incredible.
It wouldn't be VPMG, it would be when you move the nodes and then that, it would be personalized the same VPMG.
Okay.
Same style.
Wow.
yeah. So if you can have a pretty good initial model.
Okay.
Inverting. It's like a small steps, but
Yeah.
still.
No, that's great.
Mhm.
One of the other concerns with that inversion problem will be the basin sediments in the top layer are clearly not going to be uniform density. And what the spatial variations are in that, what are they? And are they too large such that they mask any sort of signal we're getting from down below? Because the density contrast between the tertiary volcanics in layer 2 and the crystalline basement in layer 3, that density contrast may be small. And one of the goals of the project is that the crystalline basement is a whole bunch of different rock types. It can be mafic metamorphic rocks, quartzite, or granite. All over the place, right? And their drilling objective is to target one of those rock types and not another. So if, considering all of the goofiness going on with the density in the basin sediments and what's going on in the tertiary volcanics, can we discern the different rock types in the basement? I think that's going to be a hard task. It may not be possible, but
Do you have a good sense of the range of physical properties within each of those units, like the expected ranges?
we would hope to get that with density measurements that'll take place this summer.
Okay. Cool.
Yeah.
And how deep is the basement? It's about
A couple kilometers. Yeah.
Are they planning on doing any other geophysics, or are they walking the course? Are they core drilling? Has the well been drilled?
Drilling's already complete.
Okay.
And so there's cuttings, there may be some core, I'm not too sure, mostly cuttings.
So they have some property analysis of the cuttings, do you know? Or did they?
I'm not sure.
Yeah. Because that would be interesting too, in terms of if they are not doing other geophysics, it would be kind of interesting. Okay, we could do this with. I mean, I'm thinking MT. That's where my brain goes all the time.
Yeah.
I mean, we've kind of talked about it, tying
Yeah.
kind of multi-geophysics more, tie them up a little bit more together.
Yeah.
If there is any sort of a relation.
Yeah. Yeah.
Is it a geothermal system per se that they are targeting? or
Yeah. The Forge project is focused on geothermal energy.
Do they expect there to be alteration, things like that, or does that?
There's certainly a lot of alteration in the rocks in that area.
Yeah.
But a lot of that alteration is likely old,
Yeah.
and some of it is probably recent.
You mentioned like in the industry, there's a reluctance using 3D softwares and or like a geophysics software. Like, do you have some idea like why is that?
It's really curious. I think it's a generational thing, and it's really curious because one of the standard things you do in geothermal energy development is you create a three-dimensional heat and fluid flow model. So you got all your wells,
Right.
and water's going to be flowing between all the wells as you pump cold water down and suck hot water out. And you want to be able to predict what the temperature decline is in that reservoir as you pump all the water and everything. So everybody in the industry accepts that you do that in 3 dimensions. And with time, they've also accepted to a certain degree that you should really do your MP modeling in 3 dimensions. But for some reason, it completely falls flat when you tell people, hey, you can do mag and gravity in 3D too.
Yeah.
Most of them just either are satisfied with looking at maps of data or the occasional 2D GMSys cross section.
What I was visiting a couple South Asian countries, and what they're mostly doing is they make a 2D section and then make a parametric model, and I'm not sure what was the software, and they kind of make a parametric model to fit this like a really smooth curve.
Yeah.
So that's what they were doing, and then so I was just like curious, kind of because like there are quite a bit of software available, like even UBC software.
Yeah.
The damming license is free, and I wasn't just like I wasn't quite sure why people like why there was a reluctance to use.
Part of it is, as I said, generational. Part of it is a software issue in that companies are reluctant to go 3D because they don't want to spend huge sums of money to buy, $100,000 software that comes out of the oil and gas industry, for example. Geothermal companies simply don't have that kind of money. And folks haven't really learned yet that there are other lower cost options. I'm the only person I know in the geothermal space who's using a 3D design software normally used to make jewelry to model geology. But I did that because I knew there was we had to do things differently. I think it's going to come with time, but and there needs to be more publications about doing potential fields in 3 dimensions in the geothermal space because there's not too many of them in order to convince people that turn on the light bulb and say, wow, we actually can do potential fields in 3D with geology and compare with all the other information. Part of the other challenge, of course, is there's not a routine acceptance of collecting rock property data.
Oh, okay.
And if you get somebody who's savvy enough who says, oh yeah, I can see the value of doing 3-dimensional inversion modeling of gravity and magnetics. Oh, but we never collected any density or mag-sus data, and I'd really like to be able to constrain it with real rock property measurements, but we don't have that data, so I'm not going to do it. Because the people who are savvy enough will say, well, yeah, totally unconstrained inversion modeling is okay, but I want to do it better than that. Oh, but I don't have the data that I need to really do it right, so I'm not going to do it. So getting people to more routinely collect density, mag-sus, and conductivity measurements as something that you just do is I think a road that we have to travel down and keep plugging.
So I think, it's also time of activeness. Like actual, I don't even know what it is, but like that's what everybody asks me about. The analytic
Plate modeling.
plate modeling,
Yeah.
plate modeling, where you just go and you just fit the spikes in your data. So I mean, but it has value. It gives a lot of intuition into the data, but if you want more details. So I think that is also, because I mean, your presentation at the GRC was super interesting. In the geophysics session, and I mean, there weren't that many geophysicists in the neighborhood. But, sorry, you showed the.
It was the Akutan, Alaska.
Yeah, and you
Yeah.
just showed the potential, the equivalent source immersion, which is just like one layer. But just when you made the point that you can now go from milligauss, that nobody understands what it is, to densities.
Yeah.
It just like, just the energy in the room just like changed. People are just like, oh, okay, like they just saw the value.
Speaking the right language.
Yeah, because they
Yeah.
were primarily geologists
Yeah.
in the room.
Yeah.
The geophysicists were all just, of course we do 3D. And then you make the point that of course we should then go to 3D. But even this like super simple geophysical tool just can bring so much value,
Yeah.
added value.
Yeah.
And just imagine what a 3D immersion that is well orchestrated and constrained, how much extra value it can
Yeah.
add.
No, you're right. So much of it is about communication and translation.
Yeah.
Because talking about milligauss, it would fall flat with a geology-oriented audience. Even talking about density difference would fall flat. And somehow I came to the conclusion I have to talk about density in order for it to really communicate with the geology audience so that they say, oh, well, yeah, 2.6, that's probably around granite. 2.2, yeah, that's shale.
Yeah.
So that they can immediately think in terms of rocks. And I think that's how I really got through to them, is to make it as close to rocks as possible.
Yeah.
So you're converting from density contrast to density use when you're presenting it to the audience.
Yeah, that's right. I chose a certain terrain-corrected gravity data set that had a specific reference density. Did the inversion, got the density difference, and then just added back in
Yeah.
reference density, and said, okay, guys, this is density.
Yeah.
But it's just so interesting because I mean, I wouldn't think about that.
Yeah,
It's
well,
same for me. Like, I can't talk about conductivity as a model. I have to talk about resistivity.
Okay.
Like if I say conductivity, I mean, even I don't always understand what I'm talking about. Like because I'm just so used to talking about resistivity, but I always invert it to conductivity and make all my models as conductivity. Right. And like,
the numbers don't add up.
and I always talk about frequencies above and periods below.
Okay. Yeah.
Like in the same sentence, I'll say like, I go from 100 hertz down to 100 seconds. Like that's how I would tell it to people. And most MT people would be like, okay, yeah, makes so much sense. But I mean, you've corrected me like so many times on that.
Frequency.
Yeah, like when you're like mixing them, like, but it's like it's just a simple relationship. Like, I have sometimes a hard time when somebody says like 0.001 Siemens meter. I really have to think about like, okay, what is that in ohmmeters? Oh, okay, it's 100 ohmmeters. Yeah, it makes perfect sense. That's unaltered lava.
Yeah.
So,
Rowan, I think you need to run. Is there anything else you want to bring up before you head off?
No, so I was sort of like just taking notes while Jeff was talking, which was like really fun to hear both the onboarding sort of side of things, what tools you're using, and sort of where like our efforts fit into the sort of the wider community, which is always a really fun thing to hear. So I shared that doc on the SimPEG general Slack. Hopefully everyone has access to that. Yeah, so that should be cool. And I think one of the other things that this is pushing on is our documentations and examples and sort of documenting all of the various knobs, which we know, but is always good to sort of get another poke, especially if you poke other people, like Dom. No. Cool. All right, I gotta go. It was really nice to meet you over Hangouts. So I'll
Great,
talk to you
yeah.
soon.
Okay,
Cool. See you around.
cheers.
Bye bye.
Yeah, I still enjoy continue chatting if you've got some time. I probably will have to run soon.
Okay.
That's okay.
I could show you real briefly the Mount Baker model.
That'd be awesome.
Okay.
I'll stop
Okay,
this.
great.
now.